Hi everyone, this time we're going to look at maximum likelihood estimator. Alright, so suppose we have a PDF, okay? A random variable xi follows this distribution, okay? And xi is a random variable here, so every xi is IID, meaning independent and identically distributed. Identically distributed meaning they have the same PDF. Independent means, they are independent, so the x1 has nothing to do with x2. Okay, so we are given a set of data x1 to xn, and we want to know the MLE of the parameter theta. Okay, theta is a parameter in the PDF of the x. Okay, so here fx given theta is equal to theta x to the theta minus 1, right? So and it has a support from 0 to 1. So first we're going to form the likelihood function. Okay, it is defined as the product of the PDF. Okay, so technically this is like the joint PDF, but because of the independence, it just simply becomes product. Okay, so it will be f of x1 times f of x2 all the way to f of xn. Now, again, because of the independence, so we can, the joint PDF is just simply the product of the two PDF, and so that's why it allows us to get the product. Okay, now the problem with the likelihood function, the big L of theta, is that this can be very hard to take the derivative. So what we'll do instead is that we'll take the log of that. Okay, so as you can see, the L of theta will be this. Okay, so theta fx1, fx2, and then if you plug it in, right, so you can collect all the thetas. It's theta to the n, and then you can collect, you see x1, x2 all the way to xn have the same power, so you can combine those as well. Now the big L of theta is gonna be this function here. Now the problem is that it is going to be hard to take the derivative on. So remember that we want to maximize the likelihood function. So that means that we have to take the derivative and set it equal to 0, right? At the maximum, the derivative of that must be 0. But since this one is a very hard function to differentiate, it's not going to work. So the trick is to get a log likelihood. So we take the logarithm of the likelihood function, okay? So we take the logarithm of the log likelihood function. This is the log likelihood function that we have earlier. Okay, so we take the log of that, and so again, remembering the rules of logarithm, right? You apply the rules of logarithm properly here, right? And then this allows us to take the derivative of the log likelihood function. Okay, so little L of theta will be equal to this. Okay, so as you can see, we want to take the derivative of this with respect to theta. It is now easier than the big L of theta. Okay, if you take the derivative of this with respect to theta, this is going to be like a bunch of product rules. So but this one is just a bunch of sums, so it is easier. So again, the same idea, right? This is the log likelihood function. You want to find the theta that maximizes the log likelihood function. Okay, and that theta that maximizes the log likelihood function is the theta hat MLE, the MLE estimator. So we do that, right? So we do some math. We take the first derivative. Okay, take the derivative of little L theta with respect to theta. Okay, and then we set it equal to 0. Okay, because at the point of maximum, the slope is 0. So we set it equal to 0, and then we solve for theta. Okay, and then theta here will be, 1 over x bar, negative 1 over x bar. So that concludes our discussion for maximum likelihood function.